Hello, welcome to the complex numbers unit. Today, in this session, we will see a little introduction to complex numbers. As you know, there are many equations that have no real solutions. Let's look at a couple of examples. X squared plus 1 equals 0 has no real solutions. We'll explain this concept in a bit. The equation x squared plus x plus 1 equals 0 also has no real solutions. For example, x to the fourth plus x squared plus 1 equals 0 also has no real solutions. Specifically, there are infinitely many equations that have no real solutions. The question is, do they really have no solutions? Can't we do anything with these types of equations? Well, let's look a little bit at the first equation. X squared plus 1 equals 0. In this case, if we pass the one that is on the right, we pass it to the left by subtracting, we have the equation x squared equals minus 1. Well, now it would be a matter of finding a real value so that when squaring it, it gives me minus 1. As you all know, when we square a positive real number, it would give us a positive number. Positive times positive equals positive. But on the other hand, if we take a negative number, negative times negative equals positive as well. That is, any negative number squared is positive. That is, we don't have numbers in such a way that squaring them gives me a negative number. Well, is there anything that can be done about that? Does this mean that the equation has no solutions? Well, it has no real solutions. Let's define a new number. What if we choose minus root of minus 1 as a value? In that case, we have that minus root of minus 1 and root of minus 1 are solutions of the equation x squared equals minus 1. That's right, yes, it's very easy to see that. Specifically, if we take just the root of minus 1 and square it, that gives us minus 1 simply. That is, it is a solution of the equation x squared minus 1. This little trick is useful for solving many equations. In fact, let's explain this concept a little bit. The new number, the root of minus 1, is called an imaginary number and will be denoted by I. In defining this new complex number, we can think, well, okay, we've invented a number, root of minus 1. Now, if we need to solve another kind of equation, do we need more imaginary numbers? Well, the answer was given to us by Gauss in 1799, and the answer is no. Simply using the square root of minus 1, we can solve any equation. And I want to emphasize that it is any equation. There is no longer any equation that cannot be solved as a combination of real numbers and complex numbers, which is what it says next. Okay, let's look at an example. Let's solve the equation x squared plus x plus 1 equals 0, which, as I announced at the beginning, had no real solutions. How would we solve this equation and get these strange new numbers that we're going to call complex numbers? Well, if we apply the formula that we know for second-degree equations, which is minus b plus minus the square root of b squared minus 4 makes 2 times a, and we take into account who is a, b, and c in the equation. We can apply the formula, and we get the following result. Notice that I've marked on the transparency who a, b, and c would be in the equation. A would be the coefficient of x squared, b would be the coefficient of x, and c would simply be 1. Well, by substituting them in the formula, we get the value minus 1 plus minus the root of minus 3 divided by 2. Notice now that minus 3 can be decomposed as minus 1, and 3, multiplying them. Well, now we apply another property that we will see later, but that I hope you know, which is that the root of a product is the product of the roots. That is, it could be decomposed in that way, as minus 1 plus minus the root of minus 1 times the root of 3. Okay, now remember that we call the root of minus 1, and therefore this could be written as minus 1 plus minus times the root of 3 divided by 2. By simply separating into two fractions, we get the number minus 1/2 plus minus the root of 3 divided by 2. Well, we will work on these numbers in future units, and we will see what their properties are, what addition and product rules they follow, and so on and so forth. I hope I've introduced you a little bit to complex numbers, and I'll see you in future units. Thank you very much.